On January 16, 2003, Space Shuttle Columbia lifted off from Kennedy Space Center at 15:39 UTC on mission STS-17. It was a routine start to a 16-day science flight, carrying 7 astronauts and dozens of experiments. The launch cameras recorded a brief, almost invisible event. 81.7 seconds after liftoff, a piece of insulating foam detached from the external tank's bipod ramp area. At a speed of Mach 246 to 645 km per hour, it struck the leading edge of Columbia's left wing. The impact lasted a fraction of a second. No alarm sounded. The orbiter continued into orbit and the crew settled into their work, unaware that the vehicle was now fatally damaged. What followed was a chain of decisions that would turn a launch debris event into one of NASA's most severe system failures. Columbia was NASA's oldest shuttle, first flown in 1981. STS-107 was dedicated entirely to microgravity research, 80 experiments in biology, physics, and material science packed inside a SpaceHab module in the payload bay. Unlike most shuttle missions, it did not visit the International Space Station. The crew of 7 included the first Israeli astronaut, Ilan Ramon, and the first Indian-born woman in space, Kalpana Chawla. For NASA, this was also a chance to demonstrate the shuttle's scientific value at a time when station construction missions dominated the manifest. The mission had been delayed multiple times, but by January 2003, all systems were go. No one imagined that a recurring technical problem, foam shedding from the external tank, would become the physical cause of the accident just 16 days later. At 81.7 seconds, while the shuttle was traveling at 2,655 km per hour at an altitude of 20,000 meters, a suitcase-sized chunk of insulating foam, about 0.75 kilograms, broke free from the left bipod ramp area. It struck Columbia's left wing leading edge at 81.9 seconds. The impact point was on the reinforced carbon-carbon panels 5 through 9, a region designed to withstand temperatures up to 1,650 kg during re-entry. But foam, though lightweight, hits like a projectile at such speeds. Ground tests later showed that a hole roughly 15 to 25 centimeters in diameter was punched into the wing's thermal protection. NASA's launch cameras captured the debris cloud, but the resolution was too low to determine the exact damage. The event was entered into the post-flight review log as a debris hit, nothing unusual, according to the engineering team's initial assessment. Foam shedding was nothing new. From the very first shuttle flight in 1981, technicians had observed debris coming off the external tank. Over more than 100 missions, foam losses occurred on nearly every launch, often hitting the orbiter. The bipod ramp area where the shuttle attached to the tank was a known source. Engineers had studied the problem, but after 20 years of flights with no catastrophic outcome, NASA's safety culture had absorbed the risk. Foam strikes came to be accepted as a maintenance issue rather than a potential threat to the vehicle and crew. As the Columbia Accident Investigation Board would later write, the frequency of these events normalized the hazard. The shuttle program had drifted into a state where major damage was dismissed as unlikely, even when evidence suggested otherwise. The day after launch, the damage assessment team viewed the high-speed launch footage and spotted the foam strike. They immediately recognized it as a high-energy impact, far larger than typical debris hits. Concerned, they requested that NASA obtain in-orbit imagery of Columbia's left wing using ground-based telescopes or Department of Defense assets. Such images could have resolved the extent of the damage, but the request met resistance. According to the CAIB, the shuttle program managers made 3 separate decisions not to pursue imagery. Their rationale was that foam strikes were common, previous analyses had shown they did not pose a safety of flight risk, and even if damage were found, nothing could be done to repair it. The crew was not informed of the strike or the debate. The decision not to image Columbia's wing was a critical junction. The managers operated under a prove to me it's safe standard, but for foam strikes, the burden had shifted to prove to me it's unsafe. As the investigation later revealed, engineers had no test data on impacts of this size and speed against the RCC panels. Their assumptions relied on smaller impacts on the thermal tiles, not the reinforced carbon-carbon leading edge. When the damage assessment team tried to raise the alarm, they found no formal channel to escalate beyond the shuttle program management. According to the CAIB, the organizational structure inhibited communication of dissenting views. The mission continued, and the window for any possible rescue or repair closed. While engineers on the ground debated, the STS-107 crew operated in a bubble of normalcy. Over 16 days, they conducted 80 experiments around the clock in 2 shifts. Commander Rick Husband, pilot Willie McCool, and their colleagues Michael Anderson, David Brown, Kalpana Chawla, Laurel Clark, and Ilan Ramon performed flawlessly. Cameras inside the cabin showed them working, talking with mission control, and enjoying the view. There were no contingency procedures for an undetected wing breach. Even if they had known, the orbiter had no repair capability for the leading edge. The only remote option would have been an emergency rescue mission by Shuttle Atlantis, but that would have required a launch readiness that NASA later judged improbable. The crew's final messages spoke of the joy of the flight. They were unaware the vehicle was compromised. On February 1, 2003, Columbia began its deorbit burn at 8:15 a.m. EST, closing a successful science mission. Ground controllers anticipated a smooth landing at Kennedy Space Center, but as the shuttle entered the atmosphere, temperature sensors on the left wing showed an unusual rise. At 8:49 a.m., the first 4 left wing sensors failed. Soon after, tire pressure sensors on the left landing gear indicated a loss of pressure. At 8:59 a.m. all communication was lost. Radar tracks showed multiple debris objects. The vehicle had disintegrated at an altitude of about 63,000 meters over Texas. Superheated plasma had entered the breach in the wing, melting the aluminum structure from inside. The crew cabin, though possibly intact for moments, was torn apart. All 7 astronauts were lost. The debris field stretched from eastern Texas to Louisiana. Within hours, NASA activated the Columbia Accident Investigation Board, chaired by retired Admiral Harold Gaiman. An unprecedented ground search recovered over 84,000 beta, about 38% of the orbiter by weight, including the crew cabin remains. The debris was laid out in a hangar at Kennedy Space Center to aid reconstruction. The CAIB included military and civilian experts, operating independently from NASA. Its mandate was to determine not just the physical cause of the accident, but also the organizational and cultural factors that allowed it to occur. The board collected launch videos, telemetry data, and interviewed dozens of NASA managers and engineers. Their work would culminate in a 248-page report released on August 26, 2003, that would shake the agency. The CAIB's technical conclusion was unambiguous. The foam strike on the left wing created a breach in the reinforced carbon-carbon panel, likely between 15 and 25 centimeters wide. During reentry, aerodynamic heating, exceeding 400 kilograde, flowed into the wing's interior, melting aluminum spars and stringers. The progressive failure started with sensor loss, then structural weakening, and finally aerodynamic breakup. Tests at the Southwest Research Institute, recreating the impact with a nitrogen gas gun, confirmed the damage scenario. The board ruled out other theories such as space debris or micrometeoroids. The root physical cause was the design of the external tank's foam, but the deeper failure was the system that allowed such a known risk to persist for 2 decades without an adequate fix. Beyond the physical cause, the CAIB dedicated an entire volume to NASA's organizational failures. It described a culture where schedule and budget pressures had eroded safety vigilance. Engineers who raised concerns were seen as troublemakers. Dissenting opinions were filtered out as they moved up the hierarchy. The board drew parallels to the Challenger tragedy 7 years earlier, noting that many of the same cultural problems persisted. It pointed to organizational silence and a lack of effective checks and balances. According to the CAIB, after the foam strike was identified, no dissenting voice was heard in the formal decision process. The report stated bluntly, NASA's organizational culture and structure had as much to do with this accident as the external tank foam. In September 2003, congressional committees held hearings on the CAIB findings. Admiral Gaiman testified that the board was surprised at the amount of things that had not been fixed since Challenger. Senators and representatives grilled NASA Administrator Sean O'Keefe on the imaging decisions and the lack of contingency planning. Congress learned that the shuttle program had cut its safety and mission assurance workforce by 50% in the 1990s. According to the Senate report, NASA's reliance on contractors and its fragmented management structure contributed to the communication breakdown. Lawmakers demanded that the return-to-flight plan meet the 15 mandatory recommendations before any shuttle launched again. This external oversight became a forcing function for change that internal processes had failed to deliver. The shuttle fleet did not fly again for over 2 years. NASA implemented all 15 mandatory recommendations, on-orbit inspection capability using the robotic arm and boom sensors, repair materials for tiles and RCC, improved imaging during launch and ascent, and a redesigned external tank with reduced foam risk. The next mission, STS-114 Discovery in July 2005, carried out the first on-orbit inspection, only to find more foam shedding, an immediate reminder of the challenge. The program never fully escaped the problem, but the framework for risk management had shifted. Columbia's loss forced NASA to confront how systemic normalization of small failures can compound into catastrophe. The CAIB's final line became a watchword. We are convinced that the management practices overseeing the Space Shuttle program must change. The story of Columbia is not only about a foam strike, it is about how a technically brilliant organization can lose its ability to see clearly. The data existed, the images existed, the questions were asked, but the system filtered them out. The CAIB called it a failure of foresight. The temperature gauge for the American space program had drifted into the yellow zone, but no one looked. Every large-scale system carries hidden risks that insiders learn to ignore. Columbia's legacy is the hard lesson that when hardware speaks, through repeated anomalies, it must be heard, not silenced by normalization. The 7 astronauts who died on February 1, 2003, did so not because a piece of foam fell, but because the system had stopped listening to its own alarms.